Alrighty, in this video we're going to learn about scatter plots and lines of fit, which are kind of a different way to take a look at lines. So up until this point, we typically started with the equation, and then we made the line based on the equation, or we had some information about the line, such as slope or points that were on the line. But the point is, we already knew the information about the line. In scatter plots and lines of fit, we're starting, instead with an equation of a line, we're starting with a whole bunch of data, and then we're using that data to create a line that models the data. So this is all about, lines of fit is all about making models for the world, which is a lot more real world application, honestly, because typically when you're making an experiment, your data is not all going to fall in a perfect line. It's going to be related to each other, but not perfect. So first variable is, or first vocab word is bivariate data. This is data with exactly two variables. Bi means two, kind of like bicycle, and variable means variable. So two variables is bivariate data, and we like to see how one variable has an effect on the other variable, or how does the input affect the output. The way that we do this is by making a scatter plot. So a scatter plot is something you've already been doing. Maybe you just didn't know the name was called a scatter plot. This is a way of putting ordered pairs on a coordinate plane. So anytime you have a t-table, right, and you have x or input and y or output, and then you have points like 2, 5, 3, 7, 4, 9, or whatever, things like this. You've got these coordinate points, and then you plot them on an xy axis with this is over 2 up 5, over 3 up 7, over whatever, and you plot these dots. And so what you're creating is a scatter plot. Scatter plot is a whole bunch of dots, not actually the line going through them, right? This is just the dots themselves. That's your scatter plot. Okay? So a line of fit, also called a trend line, is the actual line that you draw through these dots. Now, if the dots, like I'm starting to be crazy here and I'm making all kinds of random dots, if you've got dots everywhere, all over the place, like this, you can't really draw a trend line that fits the data because there's no pattern. It's all just kind of random. So we'll look at some other examples where the data seems to cluster around certain patterns or relationships, and in those cases you can draw the line of fit. So this is a line through your data, a straight line, mind you, a straight line through your data to represent the pattern. Alright, so when you're doing this, what kind of things will we be talking about? So linear extrapolation, another vocabulary word. We had this one a couple sections ago, but since this is really where we'll be using it in this section, I wanted to remind you. This is using a linear equation, which was your line of fit, to make predictions outside of the data range. And the corresponding vocabulary word, linear interpolation, is using that linear model to predict values inside the range. So again, extrapolate, extra means outside, interpolate, inter means inside. And you might be wondering, why do I have to interpolate that's inside the range of my data? And that's because you haven't maybe taken a data point at every possible value. Maybe you take data points at 1, 3, 5, 7, and 9. So interpolation would be figuring out what happens at 2, 4, 6, or 8. And extrapolation would be what happens before 1 and what happens after 9. We'll look at some graphs on the next slide, which will help kind of make this more clear as well. So when you do this extrapolation or interpolation, there's three possibilities that you can have. You can have a positive correlation between your two variables. This means when one variable goes up, the other goes up as well. You can have negative correlation. When one variable goes up, the other goes down. This is kind of like inverse variation, but not exactly the same, and that's something we'll get to much later in the year. And lastly, you could have no correlation, so here it's kind of random. So you should write these down, but really they'll become clear on the next two slides when I show you pictures. Okay, here we go. Let's start with this one because it's a little easier and more salient. Whatever that means. I just like to say it. This is a graph to show positive correlation, negative correlation, or no correlation. So if the line that you would draw through them has a positive slope, then we call it positive correlation. This is called strong positive because all the dots are very, very close to the line. Here, there's a clear upward pattern. There's a clear upward pattern where as this x variable gets bigger, the y variable also gets better, but it's not quite as consistent, right? Sometimes you have points that are not following this pattern, but the overall trend is there. And here there's no correlation. I could draw a line this way, and you might think that looks good, but I could just as easily draw a line this way, or this way, or this way, and all of them have kind of the same look, like the dots are no closer to one line than they are to the other line. Now here's a negative correlation. The line that you would draw to show the pattern has a negative slope. Okay? This one has a negative slope as well, but you can see for this one the dots are closer to the line. Here we have some outliers that aren't really close. And curvilinear relationship we're not going to talk about in this class, or at least not until the end of this class, but this might be a parabola. Okay, something like that. But for now, I just stole this picture off the internet, yeah? So for now, we're not going to be looking at this one. Let me put not now. So you don't even need to copy this one into your notes. These you should copy into your notes. At least one of the positive correlation graphs, one of the negative correlation graphs, and then no correlation. So going back to how I drew those lines, let me go back a slide. When you look at line of... never mind, sorry. It's coming up. So, positive, negative, and how I drew these lines I'll talk about in the next slide. So, second example, a graph to show extrapolation and interpolation. So, suppose we're making some measurements about the amount of money we earn based on the temperature. Maybe we're selling, I don't know, we're selling lemonade. The hotter it is, the more lemonade we should sell, right? So, we can make a trend line following this pattern that goes like that, right? And so, I know that if the temperature is 12, I actually sold around $200 worth of lemonade. But what if the temperature is 13, okay? I can use this trend line to predict that I'll maybe sell $220 or something like that. So if I want to know, okay, what happens right here, or what happens right here, things like that, in between two data points, that's called interpolation, in between two data points. And then what if the temperature goes even higher? Maybe it's 28, and then maybe it's 30. I could extend this graph and I could make predictions about how much sales I would make as I went beyond, or extrapolate outside of the range that I actually have data. And are these extrapolations and interpolations actual data points? No. We're just using the line to make a prediction. It doesn't actually guarantee that that value is going to be there. It's just to use to make a prediction to get a feel for what would happen. Okay. Now we do the problem-solving tip. So that was kind of, those graphs were part of the vocabulary word, because when you define a vocabulary word with an image, it's a lot more clear. So problem-solving tips. When drawing your line of fit, that's the line that goes through your data, it really should have two properties. Number one, it should follow the pattern. That's obvious. That's what I was doing before. But to make it the very best line of fit, you want to have an equal number of data points above the line and below the line. So obviously, if my dots all look like this, I can draw a line through them like this, and that does follow the pattern, but all the dots are below it, right? So I want to draw a line through so that I've got, 3 or 4 dots below and 3 or 4 dots above, yet still following the pattern. So if you meet both of those criteria, equal dots above and below, and following the trend or pattern of the data, then you should have what's called the line of fit, or the line of best fit. To find an equation for this line of fit, because typically the process will go like this. Number 1, plot your data. Number 2, draw the line. Number 3, find an equation of the line. And number 4, use the equation to make predictions. To find the equation of your line, you want to use 2 points that are on the line, and you want to use 2 points that are far away, right? So here's 1 point, and here's 1 point. Okay, you do not use actual data points. If you use 2 actual data points, you'll be finding a line through those 2 data points, not the line of best fit. Second thing is, you want to choose these points far away, because when you're finding the slope, which is rise over run, the farther away these 2 points are, the more accurate you'll be. If you choose 2 points that are right next to each other, right, then if your rise or run is off by even a small amount, it'll dramatically change the direction your line is heading. But if you choose 2 points that are far away from each other, you almost guarantee that you get an answer that's accurate based on your graph. So choose 2 points that are far away from each other, far away, and that are definitely on the actual line of best fit. And then lastly, use your line of fit, the equation that you derive from this, to make predictions, which are either extrapolations or interpolations. Alright, I guess I don't have any more examples because all the problems are word problems where you're plotting. So maybe I'll just write this down. Number 1, plot data. Please write this down as well. Plot data. Number 2, draw line of fit. Number 3, get equation for line of fit. And then number 4, use line to predict. Alright, so you've got your input and your output, your x and y variables. make everything labeled and nice and neat and organized. And of course in the homework, just a friendly reminder, you probably have to draw whatever graph it is that it's asking you about. Okay, that's it for now. See you in class.